class.
Professor, I have a question. What is rotational inertia?
You know, I actually have a few theories on rotational inertia. The only problem is that they haven't been getting momentum. So, rotational inertia is the amount of force that's needed to rotate an object. Here's some conveniently written down formulas. So the inertia is the mass times the radius squared. So if the mass is constant on something that's rotating and you increase the radius, well, the inertia will increase significantly. But if the radius is constant but the mass increases, the inertia also increases. So math is cool and all, but the thing is we can actually prove that these forces exist in real life. Take this conveniently placed book. Now, with an object that rotates, it requires a lot more force in order to move it when all the mass is spread out or the radius is greater. So if I were to go like this, it would require a lot more force to do that than this, because the radius is much larger. Now, let's say we're going to rotate this on the center of mass. There's three ways we can do it. We can rotate it like this, or like this. Now, which one's going to have the greatest moment of inertia? Well, it's going to be this one, if we rotate it like this. And the reason why is because all of the mass is spread out on this plane, and the radius is much larger on all of the corners. Now, how else can we prove that the equation exists? Well, if I were to throw this book up in all of the three axes, well, the one with the least moment of inertia will be the one that deviates from its rotation. So let's rotate it like this one at first. So notice how it continued to turn like this. Now let's do this next one, like that. So that one was really stable. Now, what about this one, with the least radius? See, that one was completely unstable because it doesn't have the greatest moment of inertia. It's very small.
Thanks, Professor. That was really helpful.